Welcome back to That Time When. Matt Miller with you in Studio 4. This is the podcast series where I take you through the archive here at Trekzone. And this is the instalment when we learned about gravitational waves. We beamed down to the University of Queensland and caught up with Tamara Davis, Professor Tamara Davis, to learn all about gravitational waves, which are an exciting new development in the field of scientific research, using a couple of very, very sensitive instruments across the planet to detect these vibrations through the universe. Let's hear from Professor Tamara Davis now.
Well, joining me to discuss gravitational waves and black holes is Professor Tamara Davis. Professor, thanks so much for joining me on the show again.
Thanks so much for having me.
Tell us about gravitational waves.
Okay, so gravitational waves form when you have something like two black holes that are spiraling around each other. As they move, the gravitational effect of them sort of ripples out, and that makes a gravitational wave pass through space. And it's actually a ripple in space itself. Its lengths stretching and contracting. And the times that we see it most impressively is when you get two black holes, they lose energy through these gravitational waves as they orbit each other, and they slowly infall and coalesce into a single black hole. And that collision event of two black holes is the really exciting stuff that was seen by LIGO, the gravitational wave detector over in the States.
So on the Trekzone Spotlight, I've been featuring radio telescopes. Mm-hmm. This is a completely different way of looking at the universe, isn't it?
Exactly. This is really exciting because it's something that we've never been able to do before. All the information that we have from space and about the world around us up there has come from light, whether it's optical light with the telescopes that have shiny mirrors, or radio light with the telescopes that are big white dishes, or if we go on in the other direction and see the really, really high energy things like gamma rays and X-rays. All that way, gamma rays to infrared, optical to radio, is all just light. So we've only ever been able to see. With gravitational waves, we're sort of now able to hear the universe or feel the universe. We have a completely new sense, a completely different way at understanding processes that are going on in the universe around us.
For someone that isn't fully versed in all of this, I look out at the lake behind us with these ripples coming off the fountain. Is that analogous to gravitational waves in the universe?
Yeah, sort of. The ripples coming across the water are going up and down. The way that gravitational waves travel is, imagine if you have like a ring and it gets compressed and then stretched and then compressed and stretched as it travels, and so it sort of squishes things in one way and stretches them in the other. And that's actually how they were detected. The gravitational wave detector has two arms that sort of go like this. And what you've got lasers going up one arm and down the other arm and reflecting off mirrors and being redetected at the center. Now, the arms of these detectors are 4 kilometers long. So, and the reason is because the changes that you get from gravitational waves are so tiny that even with over 4 kilometers, the change that you get is smaller than the change, the size of a proton.
Oh, wow.
And to think that we can detect those differences is just a huge technological achievement. But the way it's done is one arm of the detector will shorten while the other one lengthens, and then that one will shorten and that one will lengthen. And you can see this ripple pattern, and you can see that varying, and that's the signal we detect to make us understand that a gravitational wave has just passed through Earth.
What does the research allow us to learn?
So we can do things that we've never done before. So we have not had many tests of how gravity works in really strong gravitational fields. So if you have two black holes coalescing, exactly how does that happen? How do they merge? Do they stretch into each other, or what goes on? We've never been able to do that before. And the second thing that we can do is now the second detection, well, not the second detection of gravitational waves, but the second type of thing that was detected with gravitational waves were merging neutron stars. Now, neutron stars are really, really funky. It's like you take the mass of the sun and compress it into something the size of Brisbane. You have super, super dense things. It's basically like having an enormous nucleus. And so you can test how the matter inside a nucleus behaves by looking at how these ripples form when two neutron stars merge. Now that one in particular was super exciting because when you have the neutron stars merge, you also get an explosion. When two black holes merge, nothing happens. You can't see anything. But when two neutron stars merge, it goes kaboom. You get what's known as a kilonova, and that's where a huge amount of like the precious metals are created. So things like gold. You can't easily create a lot of gold in a normal supernova explosion or that sort of stuff. So when you talk about us being made of the elements that were created in stars, a lot of the things like gold have to be created in these merging neutron stars.
Talking science really has become a big part of Trekzone. No longer am I just focusing on even just Star Trek. It's science fiction, space and science as well here at Trekzone. If you want to find more podcasts just like that, search for Talking Science. You'll see all of the cool stuff. I've got a couple of playlists as well, Talking Science interviews and Talking Science, which is the news show on Tuesdays with Dr. Brad. It's become a bit of a real passion for me as well, this science and space sector. Something that Australia is really striving towards now that we have an Australian Space Agency to coordinate everything. Plenty of exciting stuff to be coming up. So excited for it. Well, you can get behind the scenes access and early access to Trekzone podcast by becoming a member today. If you're watching me on YouTube, click the join button down below this video. If you're listening to this as a podcast, beam over to the trek.zone/support. That takes you straight through to the subscription page. It's less than a cup of coffee a month, 1 cup of coffee a month to support Trekzone, make cool podcasts. The membership base is growing. Would love to have you on board as well. $3.99 a month for behind the scenes goss and early access to our podcasts. More Talking Science stuff like that. Talking Science Quick Takes has launched recently as well. When I don't have someone to talk to like Professor Tamara Davis, I'll tell you about it in a bit of a quick dive. About a 3-minute podcast, a quick take. That's why it's called a quick take on stuff that is making news in the space and science realm. Well, let's have a chat in the comments. What do you think of gravitational waves? What do you think of other scientific discoveries and these radio telescopes and listening stations around the world? They're not listening to us, they're listening to the universe and trying to find out some secrets. Let's have a chat in the comments. For now, though, and as always, I'm Matt Miller for Trekzone.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favorite podcast app 5 days a week. Just search for Trekzone and subscribe.